go through graphical distribution fitting. There is an Excel file. I don't think I've got time to open that and go through it with you, but it is in the training material if you download that. And it has the empirical CDF that we're going to talk about here, calculated for several distributions. So given a set of data, how do you tell what distribution it is descriptive of it? There are several ways to do it. Numerically, there's chi-squared, the KS, which would be Kolmogorov-Smirnov test, Anderson-Darling. Those would require having a loop, programming loop, where you tested different values of the parameters of the distribution and looked at the fit value for your data, and then found which one, an optimization loop to find which set of values optimally fit that data. We're going to talk in this set of slides about making probability plots and using those to get a rough idea of what distribution fits the data. So the procedure for this is to sort the data and then create an empirical distribution, plot the data on a modified XY scale. So you transform the Y values or the X values to plot in a straight line if they fit that distribution. And then you use a regression or just plot a line to see how well your data is, how linear your data is on that transformed axes. And you repeat for whatever distribution types you want to try to fit. So for example, here we have some values that are sorted and ranked. The function used to calculate this empirical CDF value is right here. So I would be the rank number minus 1/2 divided by the number of samples. And you get values that don't go all the way down to 0 or all the way up to 1. And then you associate each of those with the sorted data. Next, you have to decide on a transformation function, or use a transformation function for the distribution that you're trying to evaluate, whether it fits that data or not. So here we have the Gumbel max distribution, e to the minus e of this. So you would take log twice, and then of the empirical CDF value, and then you see you have a linear equation on the right. So you can plot that on a graph and check how well the data fits to a linear model. So here we have several distributions for the same set of data, and you can just comparatively look at each of these functions to linearize. You can see like distribution, phi inverse, log normal distribution, you take the log of x, etc. And then you can see which of these distributions sort of fits the data the best. But it's still subjective, and even though you can quantify in R-squared, it's not really a robust way to fit a distribution. It just gives you a rough idea. So like I said, there is an Excel example. I'm not going to go through it in the interest of time, because I know towards the end of the afternoon, everybody's going to be getting tired, and we might be struggling to finish on time. So I will skip that.